So this talk is building better CLI apps. My name is Michael Molisani. I work at Bloomberg. I'm a software engineer. Introductions. I'm a senior software engineer at Bloomberg. I've been working here since 2016. Well, not here. I've been working in New York. And I'm also an open source contributor. Rob mentioned a lot of the TypeScript contributions. I've made some. They're a little bit smaller, but still contributions to TypeScript. I've been working in JavaScript infrastructure and tooling at Bloomberg since 2019. This is the team. We have several internal UI frameworks, and we're the team that kind of backs up one of the big ones. Like all of the applications that Rob mentioned on the terminal, those all use one of our UI frameworks. Also, within our team, my niche is being responsible for managing the kind of TypeScript experience. So several years ago, it was, as Rob mentioned, just JavaScript. People were writing JavaScript, and it really helped people, rapidly build out all of their applications. But at some point, you build out these applications, they grow, they get very large, and a large JavaScript application can kind of become unwieldy if you don't have any types. So one of the things that was important was making sure that the TypeScript experience working with these projects could be good. People could adopt TypeScript, make their projects statically typed a lot better. But as part of the whole suite of tools that we provide to application developers, we have a bunch of tools. So we have a CLI tool, we have some editor extensions for Microsoft's Visual Studio Code, various different things to help people with editing their applications. So getting on to CLIs, the whole point of this talk. The first thing I'll mention, if you haven't heard of this website, clig.dev, I'd highly recommend going to it. This is kind of the foundational opus, that I based a lot of these on. It's essentially a collection of the different guidelines of how CLIs should behave. It was written by these wonderful people who are credited here and on the site. If you haven't heard of this before, I'll go through some important takeaways from this document. So the big thing is you want to have human-first design. It should be human-readable output. That is like the most important thing. You can have computer-readable output later. That's fine. But you want to make sure that if a human's going to be using it, a human should be able to read the output. There should also be a good ease of discovery. So if someone's using this application, they should be able to figure their way around. So have terminal-based documentation. You're familiar with man pages, but also just being able to say help and get something that can actually help you out. And to have a consistency across programs. So in this case, this is just more like terminology. We have arguments, and for this point, we're going to say arguments are the positional parameters to a command. And then separately, flags are the named parameters. In general, you should prefer flags to args because you can, move them around, have them in different orders, and they're not so dependent on the order that you pass them in. But generally, you should be consistent across subcommands. So if you're using a flag in one, you should use a flag in another. If they should be the same flag, make sure they're called the same thing. Things like that. As well, the application should be robust. And this means that you should validate user input. It shouldn't be flaky. It shouldn't be hard to use. It should help the user when possible. So with all of that out of the way, that's kind of like the base level guidelines. Is there anything we can kind of add on top, extrapolate or add to these when we're talking about a CLI framework? The first one that I like to propose is just saying commands are just functions. So every command that's exposed by a command line interface should just be a function underneath. And you can kind of abstract this away in a sense. They should be interfaces to run functions from the command line. That's where the name effectively comes from. Users provide inputs. And just like we said before, they should be named unordered flags and also positional arguments, however the function's defined. And these arguments that people pass on the command line should translate directly to arguments for the function that you're calling. And so with that, we can say the second thing. When parsing, the form of this framework should follow the function. And by that, I mean, if the function and the command line arguments are linked, then the functional arguments should determine the command line arguments. And that seems kind of almost like cyclical reasoning or something like that, but it's not something that you just take for granted in a lot of things out there. We should make sure that these two things are linked. So if you are given a set of arguments, the function takes these arguments, something that parses those arguments should validate them. Make sure that all of the arguments are ready to be passed into the function. If anything is invalid for whatever reason, you should catch that before executing the function. Last thing you want to do is have some unexpected thing break inside the function, which means any missing arguments, any extra superfluous arguments, or things that are kind of structured incorrectly, anything like that. As well, the documentation should be derived from these validations. So we're saying, here's what we're expecting in specific terms to validate these things. Why not just have the documentation be driven from that specification as well? And the last thing, which is kind of a little bit separate from everything else, is no magic features or patterns. This is kind of a personal thing, but it's also something we came to agree with on our team. People should be able to understand and debug a library using tools that are native for the language of that library. And that's honestly a very vague statement, I understand. But here's kind of what I mean. You can have too much code, and it can be hard to read. But if you don't have enough code in some cases, that can be even worse. People are probably familiar of DRY, or don't repeat yourself. That's a useful thing. It's a useful principle to have. But that can be taken to extremes, and that can end up being more harmful than beneficial. So it doesn't always justify coming up with some new advanced thing that lives outside the language to help deal with something that's maybe a little bit repetitive if it makes it ultimately harder. As well, it helps us minimize dependencies on external systems. If we stay within the language that we have, then we get to use all the things in that language. And ideally, if we have something new in that language, we can improve the language, make it better. If you have external systems, it reduces portability, and it locks people into certain patterns and tools. And notice that for the last three principles I said, which are here, none of these are specific to JavaScript. I am going to be talking about JavaScript and TypeScript today, but the principles themselves aren't specific to JavaScript. So now that we know we're going to do JavaScript, let's get into some additional things. So we know that we're going to be writing a CLI running on top of Node. And it doesn't really have to be Node. It could be something else. There are other things in the ecosystem today. Bun and Dino exist, and people are using them. We also want a strong focus on high-quality TypeScript support. We write TypeScript. We want our application developers to write TypeScript. So having the tools that we use and that they use be written in TypeScript well is important to us. So we want to say that the arguments and flags that we pass in should be fully typed. We also have a need for a lot of different commands. These are full CLIs that have a lot of different features built in. We want to make sure that we can have one CLI that supports all of these different functions. Ideally, we would like to have zero or minimal dependencies. We don't want to have to bring in a whole bunch of stuff that needs to get loaded every single time someone wants to run any command, because that slows things down. And like I said, we don't need every feature imaginable. There are a lot of command line tools out there today that have very fancy tools that are very fancy features that do a lot of things, and we don't necessarily need every single feature. And we also want to be more aware of our software supply chain. When we have a lot of dependencies, that's a lot of potential avenues where some package publishes a malicious version, and now all of a sudden we have to scramble and figure out, how do we get this fixed? How do we roll out something and make sure everything isn't broken? And we want to see if we can optimize performance. Parentheses, lazy loading, I'll get back to that. So we, within our team, had a CLI that was used by a lot of developers at Bloomberg, and we were looking to rewrite it because it was currently using like a hodgepodge of 3 different libraries, and we were thinking, oh, okay, is there something else out there? We're going to have to be rewriting this. We don't want to have to rewrite this and then a few years down the road rewrite this all over again. So given all of these principles, can we come up with what is the best thing that exists out there today? So let's take a look at some prior art. These are a selection of NPM packages that deal with command line parsing. The very popular Commander has 143 million weekly downloads. Yargs is also very popular. I also searched for ones that I wasn't as familiar with. This one right here, for example, is not pronounced Sade. It is pronounced Sade. But yeah, there's a lot of these, including DocOpt, which has been ported from multiple different languages. But what can we say about these? So a lot of them use method chaining, which, if anyone is unfamiliar, looks like this, where you have methods and you just keep chaining them on and on and on. And I'm not saying that this is inherently bad, but working and doing TypeScript support, doing static type checking with these is very hard. It's not impossible, and there are libraries that use this pattern to do type checking in very clever ways. Think something like Zod, for example. But a lot of the existing CLI libraries were built to match patterns from, just say, Python, where this is how things were built up, like a builder pattern, and there wasn't really much consideration for how would this work with TypeScript types. Yeah, like I said, these would provide runtime validation, but there wouldn't really be accurate TypeScript types. Some of them had TypeScript types, but you'd have to define them in one place and make sure that it matched somewhere else. And this means that it could easily fall out of sync, and you'd have to make sure that the types actually matched. So off the bat, this kind of eliminates these libraries from consideration. Or not necessarily eliminates them, but we wanted to look past them and see if there was anything else. Another red flag is custom DSLs. So random different characters on the command line. It's a fact that like CLIs predate JavaScript. Well predate JavaScript. Terminal users have been using the terminal for a long time. And there's many other languages that have CLI, that have command line interfaces. Oftentimes, libraries rely on some custom DSL, which is defined to be like, oh, the parentheses mean optional, or the dashes mean flags, and different things like that, mirroring what you would see in the help text or how you would use it. It is a little bit more friendly for non-JavaScript developers because it is not JavaScript code, but you now need to learn this custom DSL. And unfortunately, there isn't one DSL that everyone agrees on. It's often each library has its own little different variant that it deals with. These libraries often use DSLs for doing this. And just by the way it works, I'm not going to be writing some like horrific TypeScript string literal parsing to look at these things. They don't really have TypeScript support, or at least they don't have it off the bat if you just use the DSL. All right, one more. Let's say argument parsing. So some libraries only do argument parsing, and that's great, but it is only half of what we need. So they're basically responsible for taking in argv and translating it to something else that's more structured that we can use in our applications. We could potentially use this inside something, but it's not all of what we need. Some of these had support for TypeScript that was really good, and some of them didn't. There's also been some standardization efforts among runtimes. Most recently, WinterCG, the web interoperability, okay, I had it right the first time, has a proposal for a CLI API. And so that meant that these libraries, arg, which is Vercel, and then there's a parse args in Node and Deno, weren't really going to fit the bill for us. So that's gone through a lot of libraries. What's left? And there were basically 2 libraries that we looked at that were big enough that were almost right. We had some final reservations. So there's Oakcliff, which is run by Salesforce, and they use it for the Heroku CLI. It's very popular. It requires only 28 dependencies. I will clarify, this slide is a little old. It now says only 17 dependencies to pull it in, which is a little on the high side, in my opinion. The way that you write an application is you have commands that are subclasses, and each of those subclasses has static properties. And that's how you define how the command should behave, what the arguments are, different things like that. In the execution, you need to call parse manually. So you actually need to do the parsing yourself, even though the setting up of the arguments is done with the static properties. And the subcommand routing is based on the directory layout of the files where you have these classes, which sounds interesting, but it also means that now you have a dependency on your file system. How you've laid out these files is how this thing runs, which sounds useful, but it now means that your file system is a runtime dependency. It does also support explicit configuration of saying this is how things are set up, but the directory layout is kind of the one that they recommend. And also, applications are defined as these collections of plugins that are loaded dynamically at runtime. Because I know that the Heroku CLI allows people to say, you can write a plugin for Heroku, and then you can just add it in at runtime. This isn't really a feature we wanted to support, and it seemed like this plugin-based architecture was kind of how you had to structure your application. And like I said, if you're adding a new dependency on your file system, having a collection of plugins means you now have a dependency on a package manager or a package resolution algorithm. This picture up at the top above me is their plugin loading algorithm. So this runs whenever they figure out what are all of the plugins that should be loaded for this application. And that seems a little messy. Like I said, it does, I will say, it does cache this resolution to file. So every time you run it, it doesn't need to do this, but it does need to actually go through this once and then save it to file. The other one that we looked at was Clipanion. I'm hoping I'm pronouncing that right, which is what powers Yarn. It's pretty popular. It has a lot of weekly downloads. It has only one dependency, which is fantastic, which is Typenion. If you're familiar with Zod, it's effectively the same kind of library. It's used for validating types. Commands are subclasses with regular properties, not static properties. And command routing is based off the static properties on that subclass. It does require that all of the commands, all of the classes need to be evaluated in order to run the application, which is a lot of things to load, especially when the implementation is inside the command. And once again, it's a collection of plugins loaded dynamically at runtime, which is this additional dependency on the plugin resolution. It doesn't have a resolution algorithm like we saw with Oak Cliff. Yes, everything has to get registered individually. So, can we build a better mousetrap? Is there something that we can do that hasn't been done? Yes, but we also don't want to just invent something for the sake of inventing something and then something exists out there. It's a very popular XKCD comic that kind of summarizes this. We don't want to have just yet another competing standard. So before we get into what else can we do better, what should it not do? If we're building something from scratch and we're going to say this is something that can exist in the ecosystem, we got to make sure we know what we're going to be building and what we're not building. So if there's anything that's orthogonal to parsing or routing, we shouldn't be doing it. So that means it should be runtime agnostic, ideally. Node is nice, but like I said earlier, we have Bun and Deno now. It should avoid interacting with the local machine, so no file system access, no custom logic for your operating system, anything like that. For persistent state, like I said, it should be runtime agnostic, and we don't want to interact with the file system, so we're not going to be writing logic to like store a file in your home directory or anything like that. That's a good use case, but we're not going to be building that. And we wanted to avoid plugins. We don't want to be tied to a specific runtime or module resolution algorithm. As well, it should not do things that have already been solved. So if you have logging, there are so many different libraries for logging, and who am I to tell you which one is better or how you should do your logging? It basically already exists. We only care about standard out and standard error. You want to put something else in some other logs, some other place, rotate them, anything, that's fine. Everything else is a gray area, and that can be solved by some other library. Any kind of enhanced formatting. So colors are nice, but what about tables, spinners, anything you've seen? There are some very fancy CLIs these days that look very nice, very animated things. We don't need to be writing all of that logic. All of these things are stylistic, subjective. What if we don't have the latest, animations or anything like that? We don't want to support that. It's just more bulk, and it's not critical, and it's already been solved by someone else. And prompting. If you want to ask the user for some input, we recommend using Inquirer with an E, not an I. There are actually 2 packages that do this. Inquirer is a lot better than Inquirer. Side note. OK, so let's get on to parameters. We want to support arbitrary types. So string number, Boolean, it's this stuff, not exhaustive. We should also make sure that the parsing gets type checked by the command implementation, not the other way around. Each argument should be parsed in isolation. It's one thing to have an application where you can say you can pass A and B or B and C, but not A and C. That's a valid thing to want your application to check for, but maybe it's not part of the CLI framework. It's something that just is validation in the implementation. It's not hard to check for that. C, Zod, or Typanian for something like that. Any other features? So we should have commands because we want a large application. We want to be able to lazy load. We want this application to be very efficient when it runs because it's a CLI that people will be running on the command line. You should not be loading every single dependency of your application. Want to generate the help text automatically. It would be nice to have autocomplete. This is one of our most requested features. It's very nice to have. And so with all of that, I think there was an announcement yesterday, we have Stricli. This is the application. This is the CLI framework that we developed internally and we released as open source software yesterday. It is pronounced Stricli, like the word strictly. There's no dancing happening today. I know this is a London audience, but yeah. So what is Stricli? It's a new CLI framework. It's got full TypeScript support, no dependencies at runtime, just Stricli. You can build your application with composable commands and routes however you want. And there's also some dependency injection in there, the shared context. So does it do anything different or novel compared to what other applications are doing? So yes. One thing that's really nice is it splits the definition of the command from the implementation of the command. It's a separation of concerns. You have the implementation, and that just cares about the implementation, and the parsing that just cares about the parsing. And we do this by having automatic lazy loading with the dynamic import, which was standardized as part of ECMAScript, and we want to make sure that we're staying within the language. The implementation can still support this. So in this case, the command is written here, and the command, like the parsing logic, is on one thing, in one file, and then the actual function, which in this case is just printing hello world, is written in another. What this allows us to do is say, from a TypeScript perspective, because TypeScript is aware of the dynamic import statement, it can read these types remotely. So it knows about flags and positional parameters, and it can type check those via the import statement. So this function run takes in an object that has name. We can make sure that the flags expect a name that is parsed as a string. This is kind of a animated example of this happening. Things to look out for, that when it gets renamed on one side, it renames it in the flags. When I add a new one, it automatically gives me a type error saying there is a new flag here that is not being passed here. This is a type error, and it's only fixed when I rename it. And when I change this flag to be optional, I automatically get an error there saying this should be optional. So it automatically type checks from the implementation that is nice, clean, pure JavaScript. TypeScript, specifically. Also other things, we have explicit command routing. So in this case, hello world and print name from the previous slides, we built those as commands. We can just pass those into a route map. and say, this is what our command, this is what our application should look like. So it takes, you run app, and it can have hello world and print name. It automatically generates this help text for you, and it supports both camel case and kebab case, because we know that in JavaScript and TypeScript, people like doing camel case, but on the command line, people like doing kebab case, so why not support both and translate in between? We also want to have autocomplete support. And one thing that's different about our autocomplete is that it invokes the runtime. It's not just building up a shell script that matches what our application does. When you prompt for a new completion, it will actually run the JavaScript code that is your application. And through our lazy loading, you're not loading any of your application dependencies. You're only loading the commands, so it's very, very fast. And what this allows us to do is you can have additional logic inside. So in this case, it's just saying, like, oh, I can do hello world and print name. Those are the two ones. And then I can do first name and last name. Those are the arguments. But just say, for example, I want to read what are the local projects that this user running this CLI has open. And I can return those and say, oh, this user has my project 1, 2, and 3. So I can specify through arbitrary code exactly what I want the completion to present to the user. And this is actually very performant. Yes. It does only support Bash for now, but that's not the end of the road. We are planning to support other ones, but Bash is good enough for now. And it's available now. You can go to bloomberg.github.io/stricli. That should not be a -G. That should be a -P. That's a typo on my part. But yeah, it's available now for anyone to use. That's it. I will skip the website, but we can take questions, yeah.
Let's see, is this, try this mic.
Ah, there we go, that's working.
We do have time probably for one question. Oh, okay, your hand
there you go.
At the front here.
Hello. The way that it that Stricli sort of flags to you via type checking that your options, as you've this one, that your parameters don't match the function is really nice. Were you not tempted to just automatically generate the parameters by passing the actual function? Why put it in twice?
When you mean parsing the function, that becomes parsing the TypeScript code. And that is something you could do, but then we're building something that lives outside of the language. And that becomes an additional dependency. That means that if you want to run this, you need to run that step before and generate these things. So it's definitely a useful feature, and I could imagine someone building it, but we wanted to kind of stay inside the language to make sure that we could take advantage of these things.
Yeah, sorry, that was one of your rules, yes.
Okay, great. So thank you, Michael.